Hi there, this is the next video on trigonometric identities. Now, identities will be something new, and we use this symbol to represent an identity. But where these two identities come from that I'm going to show you actually come from the unit circle that you should have seen before. So you should have seen the links between this and your sine, cos and tan graph, and also the links between this and the cast diagram. So just a very quick summary, a unit circle is where we've got radius 1 and the centre is the origin. I've just drawn two dashed lines so I form a right angle with angle theta, and this is just a general point xy. Remember, you can move this around anywhere, anti-clockwise, clockwise around the unit circle. If it was there, then this horizontal length of the triangle will be x, this vertical length of the triangle will be y. And if I apply trigonometry here, I can form some trig ratios linking x and y. So if I think about sine theta, it's opposite over hypotenuse. So sine theta equals y over 1, which will be just sine theta equals y. Then if I think about cos theta, that's adjacent over hypotenuse. So looking at the unit circle, it'll be x over 1. So I'll get cos theta equals x. If I do the same for tan theta is O over A, opposite over adjacent, and that will become y over x. Okay? Now I'm going to show you where I can form some identities from that information then. So the first part is going back to Pythagoras. So I can do Pythagoras' theorem on this triangle here. So a squared plus b squared equals c squared. In terms of what we've got, it'll be x squared plus y squared equals 1. Now I've just found what x and y are in terms of sine theta and cos theta. Sine theta is y, cos theta is x. So if I've got x squared, that must mean I've got cos theta all squared. And we've seen how we can write that differently with the powers of trig functions. If I've got y squared, then it'll be sine theta all squared. So if I put that into here, I'll have cos squared theta plus sine squared theta equals 1. Now this is the first identity. I'm just going to write it slightly different way around because we're used to seeing it more with the sine squared theta first. And I'm also going to put the identity symbol in. So that is your first trig identity. Sine squared theta plus cos squared theta equals 1. The second identity comes from just looking at this bit here, the tan theta bit. So tan theta equals y over x. I already know what y is and what x is. So the next identity, when I substitute those in, change to an identity symbol, will be y, which is sine theta, divided by x, which is cos theta. So we're going to be looking at how we can use these identities going forward. Just make sure in your notes you've got the top bit written down, so your unit circle annotated, these trig ratios, and then you've got two sections for where your identities come from. Okay. So I'm going to simplify the following expressions, and I want to be using the identities. Just so we've got them, I'll write them at the top. Sine squared theta plus cos squared theta equals 1. and then tan theta equals sine theta over cos theta. So I'm going to be looking at how I can use these, and they can be rearranged if necessary. This one is the one that will be rearranged. It's very unlikely that you write tan theta in a different way to how it's written there. So if we look at part A, you can see that the angles are the same here. I've got a 3 theta. In my identity, I just have a theta, but that could be anything. It could be x, it could be 2 theta, it could be 4 alpha. As long as I've got the same angles, I can apply the identity. So if sine squared theta plus cos squared theta equals 1, sine squared 3 theta plus cos squared theta is going to equal 1. So that's 1. This one, I'm looking at this bit and comparing against the identities. I've got a sine squared theta in my identity. Now I don't have a cos squared theta, so I'm going to rearrange this. I'm going to say sine squared theta equals 1 minus cos squared theta. So I can be using that. But what I might do first, looking at it, is I think I can factor out a 5. So to take a 5 out, I'll have 1 minus sine squared theta. And actually then I want that the other way around. So cos squared theta equals 1 minus sine squared theta. So if I put this and change it for that, then I'll just be left with 5 cos squared theta. Okay, so these are the steps. Factorise first, because then actually you can see it a little bit better. And then sub in your identity. Now let's just see if it worked the other way around. So I'll just do it in a different colour. If I was using this, I would have 5 minus 5, 1 minus cos squared theta. That would be 5 minus 5 plus 5 cos squared theta. And those will go, so yeah, I still get the same the other way around. Okay, so 2 options there. I'll just repeat that in case I confused anybody. I saw a sine squared theta, so I made it in terms of 1 minus cos squared theta. You can substitute it in there and get the answer. Or if you factorise out the 5 first, you'll see a 1 minus sine squared theta. So if I rearrange the identity in terms of cos squared theta, then I can sub in cos squared theta. And notice how you get the same answer here and the same answer here. Okay, I'll move on to the next one. So I'm looking at the denominator. I've got some squareds. I've also got the same angles, so 2 theta. So I'm going to leave the numerator as it is. And then I've got the square root of 1 minus sine squared 2 theta. Well, that could be written as cos squared 2 theta. Okay, if you've not spotted it, I'll do it down here for the time being. So if I've got sine squared 2 theta plus cos squared 2 theta equaling 1, I've just changed the angles. Then if I rearrange cos squared 2 theta equals 1 minus sine squared 2 theta. So this cos squared 2 theta I can replace with what's there. So I will say it's equal to the square root of cos squared 2 theta. And this, remember, can be written as cos 2 theta all squared. So I've got the square root of something squared. We'll just make a bit of space. The square and the square root will cancel. So I'll be left with just cos 2 theta. And if you spotted it, I've got the same setup as the second identity, which I haven't used yet. So tan theta equals sine theta over cos theta. My angles are just 2 theta. So this is the same as tan 2 theta. Okay, so just practicing using the identities, spotting where we can substitute in. The next example is saying express each of the following in terms of cos x only. So I'm only allowed a cos x in my answer. There might be numbers, operations, all those things, but I can't have a sine or a tan basically. So if I go to the first one, thinking about the identities again, now I can see a tan squared x. If I just write the identity I've got for tan in terms of x, it's this. Now if I square the tan x, it'll be the same as all of that squared. And I can square each individual part of the fraction. So tan squared x equals sine squared x over cos squared x. So you can be making a note of that in your notes. So I've got a 2 here, so it's going to be 2 lots of sine squared x over cos squared x. And I still need it in terms of cos x. Well, the denominator's fine, but I need the sine squared x to go. So if you spotted it, this can be written as 1 minus cos squared x. I've just rearranged the first identity that we saw. So that's 2 lots of 1 minus cos squared x over cos squared x. Now I'm going to leave it like that. You can multiply by the 2, so it'll be 2 minus 2 cos squared x on the top over cos squared x if you want. Okay, if I go to part B, I can already see I've got a sine squared x, so I can be using the same identity here. And then I've got a tan x, so I can be using sine x over cos x there. So this can be equal to 1 minus cos squared x minus sine x over cos x. This is fine, the first part, 1 minus cos squared x, it's fine. It's just the numerator bit of the fraction that needs to change. Just have a think, see if you can get creative. How can I change the sine x? Okay, well done if you spotted it. It's not massively common. It comes up from time to time, but you can change sine x to a square root part. So if we look at this over here, that's when I've got a sine squared x. Well, if I've just got a sine x, if I square root the left-hand side, I am going to square root the right-hand side. Now, when I square root, I'm going to have a plus or minus So I'm going to change the numerator for that. It's going to be minus and then plus minus square root of 1 minus cos squared x over cos x. Not very nice, but we've wrote it in terms of cos x. Okay, we're going to continue with some more questions. I think there's 2 more. It says, given that P equals 3 cos theta and Q equals 2 sin theta, show that we get this. Now remember, we show that questions, we want to end up really with that answer. So I don't even want to use the 4p squared plus 9q squared equals 36. I want to show that using the other 2 things that I've been given that I can get there. So I'm going to take P equals cos theta and Q equals 2 sin theta. Sorry, I've realised I've missed off the 3 there. P equals 3 cos theta. I'm going to take these 2 and see how I can link these to the identities that we've seen. Because I'm looking, this looks almost like one of the identities. We've got 2 squared terms added together equals a number term. So I want to get this P actually in terms of cos theta. So I'm going to do cos theta equals P divided by 3. I've just divided both sides by 3. And this one, if I do sin theta, it's equal to Q divided by 2. I've divided both sides by 2. Now if I use the identity, sin squared theta plus cos squared theta equals 1, I'm going to replace the sin squared theta with whatever q over 2 squared is. Okay, so I'll just put that there, because sin theta needs to be squared, so does the right hand side. And then same with the cos squared theta, it'll be p over 3 squared. And then that will equal 1. Now if I sort this out, q over 2 squared, using index rules, is going to be q squared over 4 plus p squared over 9 equals 1. Now I'm looking and comparing against what I've got in the question. How am I going to get a 36? You might have spotted it. You can times through by 4, then times through by 9, or times through by 36 altogether. I will break it down. I'm going to times by 4 first. Times by 4, I'll just be left with q squared plus 4p squared over 9 equals 4. If I then times by 9, I'll get 9q squared plus 4p squared equals 36. Now if I just compare against the question, I am right, I've just got the terms in the opposite way around at the front, just checking. So I'm just going to say therefore 4p squared plus 9q squared equals 36. And I've shown by starting off with p equals 3 cos theta and q equals 2 sin theta, how I get to this equation down here. Another one, final one, eliminate theta. So I'm not allowed a theta to give an equation relating x and y. Well, if I'm eliminating theta, that means the trig ratios will go as well. So I'm only allowed an equation in terms of x and y. And again, they can be operations, they can be numbers, but I just can't have theta or the ratios. So I'm going to see how I can combine x equals tan theta and y equals cos theta. The first thing I'm thinking is that I can rewrite tan theta using one of the identities. Okay, so tan theta equals sine theta over cos theta. So that means then this will be part of my steps. X, I'll write it down, can change to sine theta over cos theta. Now, cos theta equals y. So I'm going to get rid of the cos theta. And write it as sine theta over y. So that's what I've currently got. Now I'm going to times by y. There are multiple ways of doing this, but I'm thinking I'm going to times by y so it's out of the way. And then I'm going to think what I can do with this sine theta. Now we did see it in the last one that we've done. When I had a sine x and I wanted to change it, I used this. So I square rooted the part of the identity. Why am I doing that on this one, or why am I thinking I'll need that on this one? Well, I haven't got a letter in terms of sine theta. Tan theta equals x, cos theta equals y. So if I can change this sine theta into terms of cos theta, I might be able to apply a y there. So just to be clear, sine theta, if you remember, equals plus or minus the square root of 1 minus cos squared theta. Where's that come from? If I write the other identity up here, rearrange, and I've just square rooted both sides. So I will write xy equals plus or minus the square root of 1 minus cos squared theta. And cos squared theta, well, I can write that in terms of y, because if y equals cos theta, and now I've got a squared cos theta, that must mean that y squared is cos squared theta. So I'll replace that with a y squared. And I think I'll leave my equation like that. It says, give an equation relating x and y. Well, now I've got just an equation involving x and y. Again, there are multiple ways of getting to this equation, or to get into a version of this equation. There'll be lots of equivalent ways of writing this, because I could still rearrange this and so forth. But I'm going to leave it as that. I've got to an equation. Okay, everybody, that is the end of this video.